This is a reverse situation of the flanker versus F35A JSF. In this case we're looking at from the perspective of China, and we'll start the simulation running. Just to once again talk about the data lengths. In this case we'll just change the centre of focus, and here we have some Chinese HS skywave radars providing data feed into a large Chinese base, which we can see here, and then going out by data link to the aircraft. Just start it off. So the setting time is 2018. The simulation is resolving the various entities. It should start to run any moment. We've still got 24 flankers, 24 F35As, 2 sentries, 6 extended tankers, and a high altitude long endurance sensor here. Let's change the centre of gravity of this, and we can turn off the data links. Make it a little clearer. This time we might zoom in a bit and just watch the missile battle. Here's a sentry over here. Watch what happens to it. A couple of missiles inbound for that sentry. That's the first target the Chinese are looking for, with the R-72 AWACS killers. Now we can slow the flight down, so this is now in real time. Just to get an idea of who's whom. There's the sentry, and they're still alive. Some more missiles coming in here. These are long-range missiles, so they'll probably head into the sentry. You can highlight a particular aircraft and see what happens to it. And there's the sentry lost. Now if we look at some of the missiles, that's an AIM-120D off the JSF, and we'll start speeding this up, zooming out so we get a more global view of it. So you've got more higher rate of activity. Just zoom in a little. This is running at 15 times real time at the moment. Over here you're starting to see as the number of F-35s is being reduced, it reduces the barrier that presented to the flankers, and they start targeting the tanker. So here's a missile going into this tanker. It often takes more than one hit to down a large aircraft. The flankers are pretty tough. They're armoured, and large aircraft of course have their own defences against incoming missiles. So one of the features of Harpoon 3 is it does damage modelling. This is quite unique in a simulation this time. So it looks at what systems are being taken out by the various missiles, and it depends on the angle that the missile's coming in and whether it's got a large or small warhead. So quite a sophisticated piece of work. Very competent doing this sort of work. So that particular tank has been attacked 3 or 4 times, and it will probably survive now. And you can see this is a flankers chasing a JSF home, and then it's run out of fuel. This one here, it's run out of fuel and returning to base because it's run either out of fuel, I would say in this case, or out of ammunition. And the air's pretty well cleared now. Everybody's on their way home. It may be an engagement between this aircraft and these returning JSFs. We'll see as they pass. Well, there was a missile exchange, but the flanker managed to avoid that. Okay, we can pause this and resign, and we can see what the results were. Okay, in this particular case we lost both sentries, 3 of the 6 tankers, and 20 F35A JSFs. Interestingly, you'll notice here that the JSFs are equipped with an L-band directed energy weapon, and that was fired 18 times. They also fired 78 AIM-120Ds. Now from that they managed to kill 14 flankers, and you'll see the missile expenditures, variety of missiles expended by the flankers. So very intense and deadly warfare, as we've seen before. The battle plan for the flankers is to get the sentries to deny situation awareness, because the modus operandi is network-centric warfare. They are picking up the JSFs with skywave radar and with their own sensors, which include infrared sensors. So in this particular case, the loss exchange rate was sort of about 1.5 to 1 in favour of the flankers. Over 10 runs, we always average these out to 10 runs. The best situation was the F-35s lost 10, the worst was 24. The best for the flankers was they lost 3, and the worst case they lost 16. So quite a lot of variability in the runs, as you expect with Monte Carlo simulations. That concludes this simulation.